Hi, Integrated Math 1. Welcome. What are we welcoming? Welcome to lesson 4.1.1b. So we're doing module 4, topic 1, lesson 1, but we're doing the second half of that. We're doing day 2 of this. So today we're going to be doing activity 1.2, and we're also going to be doing our talk the talk. And we're on page M4-11. Again, we're in volume 2 of our workbook, so make sure you're in the right place. So we talked about histograms last time, and actually our getting started activity last time also had the dot plots. It's weird we call them dot plots because we put little X's, but you get the idea. Today we're going to be talking about box and whisker plots. So here's the deal. The governor wants to compare the amount of lead in the drinking water of different cities in her state to see where improvements in the water systems should be made. If you recall from last time, we did find a city that had some scary levels of lead in their drinking water. We don't want it to go over 15 parts per billion. So we're going to compare some cities and see what's going on if we can figure that out. Now, because we have two different cities that we're going to be comparing, a histogram isn't the best way to go anymore. A histogram is great with those bars. It's great if you just have one set of data, but we're now dealing with more than one and we want to compare them. So if you want to visually compare two large sets of data, just at a glance, use a box and whisker plot. A box and whisker plot is a graphical representation that displays the distribution of quantitative data based on what we call a 5-number summary. So a histogram did these big bars, right? It was a big bar graph. A box and whisker plot spreads it across a number line, similar to the way a dot plot does with some key differences. But again, it just kind of helps us see where our chunks of data lie. Only now it's going to be horizontal instead of vertical with our histogram. So we use a 5-number summary to do this. And literally, you need 5 numbers. And if you have these 5 numbers, you can construct a box and whisker plot. So the 5-number summary consists of the minimum value, the lowest value in your data set, what we call the first quartile, we'll talk about that in a minute, the median, and if you recall from earlier math classes back in the day, remember that median is the middle number in your set. If you've got everything lined up, it's always that middle number. The third quartile, which we'll talk more about in a moment. We often use Q1 for our first quartile and Q3 for our third quartile. And of course, the last number in our 5-number summary is the maximum value, the biggest number that you have on your set. So with this in mind, I have a worked out example for you here. So here I have a 5-number summary that's been used to create a box and whisker plot. So each vertical line, vertical, 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 each vertical line of the box and whisker plot represents a value from our 5-number summary. So of course, this first one is the minimum, right? This is as low as it goes. This last one is the maximum. It's as high as it goes. We said the median was the value in the very, 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 very middle of our set. So if you listed all of the numbers in your set, the median would be middle. And so here it is right in the middle. Now let's talk about these quartiles for a moment. Q1, that first quartile, is the median of the lower half of the data set. So this number is the middle between the middle value, right? Between the lower half. So from the minimum to the median, that quartile 1 is the median for the lower half, which means quartile 3 is the median for the upper half of the data set. So if I were to look at all the numbers from my median to my maximum, which value is right smack dab in the middle of those numbers? And that would be your third quartile, your Q3. Now, when we do this, notice how we have a box going from quartile 1 to quartile 3, and it includes our median. And then we just have a line on either end. And what this does is it creates 4 sections of our graphical display, okay? The first section is our minimum to our first quartile. The second section is our quartile 1 to our median, the first half of the box. The third section is our median to quartile 3, our second half of the box. And of course, our last section is that last line from the third quartile all the way up to our maximum value. And what this does, because it looks kind of weird, because you're like, it's not really in the middle, it's the middle value. But what this does is that each section, so like this line, this half of the box, this half of the box, and this line on the end, each section of that box and whisker plot represents 25% of the data set. So 25% of my values would be here, another 25% of my values would be here, another 25% of my values would be here, and the last 25% of my values would be out on the end. Okay, so literally, that's why they're called quartiles. We're breaking it up into quarters. A quarter of my information, a quarter of my information, a quarter of my information, and a quarter of my information. All right, so this is why a box and whisker plot is kind of cool, kind of easy to use. So what I would like you to do, I have here 2 5-number summaries of the data for the amount of lead in drinking water samples. So here's the 5-number summary for the city of Greenville and the 5-number summary for the city of Oaktown. And what you're going to do is you're going to make 2 box and whisker plots. You're going to make a box and whisker plot for Greenville. You're going to make a box and whisker plot for Oaktown. And I want you to put them right on top of each other on a number line. Okay, so go ahead and hit pause to work this out, and then hit play when you're ready to check your work. Busting out the pen. Let's do this. First of all, I am going to go ahead and number stuff. I can see I'm going 1 all the way up to 22. So I'm just going to start counting. 1, 2, 3, 4, 5, 6, 7. You don't have to label every single one, but I'm going to go ahead and do that just because I can. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. Oh, that's so nice that they gave us a number line. That fits perfectly with our needs. So kind of them. And let's go ahead and let's make our box and whisker plot. Let's start with Greenville. I'm going to use my blue for Greenville just to make it easier. So we're going to put just like a little vertical line at each of these spots. So we said there's a minimum at 1, and I'm going to put it above. So I'm going to put a little line there. The first quartile is at 8, so I'm going to put a little line here. The median is at 12, so I'll put a line here. The third quartile is at 16, so I'll put that, oh, sorry, that didn't work out, put that there. And my maximum is all the way up here at 22. Now, we said it's a box and whisker plot, so we said the box goes from the first quartile to the third quartile. So I'm going to go ahead and close those off and make a lovely box, which I just did. And then it's a box and whisker plot. So I'm going to put my whiskers on the end for that first section and then for that second section. So, and I'm going to make a little label here. I'm just going to point out that this is Oakville, just so I can remember, hey, this is Oakville. That's not Oakville, it's Greenville. Oh my gosh, Miss Scott, you don't even know where you are. That happens. Sorry, so we'll fix that. So this is Greenville, except I can't write it very well. Greenville. All right, I'm going to grab another color. Let's grab a red. That sounds good. And let's do Oaktown now. And we'll do the same thing. We'll just start just by making our little vertical lines, and then we'll draw our box and our whiskers. So now our minimum is at 2. So I'm going to put it up above Greenville. I do want to compare them. So I'm just going to put this right above Greenville. Our first quartile is at 6. So I'll put a little line there. Our median is at 8. So I'll put a line here. Our third quartile is at 9. Oh my, put that right there. And our maximum is at 15. So again, we'll do a box between our first quartile and our third quartile, and that median gets trapped in the middle. And then we'll do a whisker from the minimum to our first quartile and another whisker from our third quartile all the way up to our maximum. And I just want to make sure I label things. So that is Oaktown. And there we go. You just made 2 box and whisker plots. And it's actually kind of cool because it's really easy to compare them, isn't it? Wow, I like this. So I like box and whisker plots. I can just have one right on top of the other, and it makes it really easy to compare the data. That's some data. So now that we have this all set up, all easy to see, all easy to read, I would like you to tell me, remember that this number line was amounts of lead per parts per billion? Suppose that you work in the governor's office. Compare the data displayed on these lovely box and whisker plots we made. And can you write just a real quick analysis that you need to present to the governor, remembering that more than 15 parts per billion is bad, and remembering that if it's over 10%, it's definitely a bad thing. So go ahead and hit pause, jot down your thoughts to the governor, your recommendations, and then hit play when you're ready to keep the discussion going. So we said 15 was bad, but if you recall, the maximum for Oaktown was 15. So Oaktown doesn't have a problem. 100% of the sites, remember each chunk is 25, 25, 25, 25. 100% of the sites in Oaktown have no more than 15 parts per billion of lead in the drinking water. Oaktown is fine. They're all below the threshold for safety. 100% of them are below the threshold for safety. But I'm looking at Greenville, and I can see this entire chunk of Greenville. Remember, each chunk was 25%? I can see right away that more than 25% of the sites are over the 15 parts per billion. I didn't even have to work out the math, right? I could just look and I'm like, holy crud, that entire chunk, every chunk is 25%. That entire chunk is way over. So I'm going to tell the governor, I'm like, look, 100% of the sites in Oaktown are good. 125% of 100% of the sites in Oaktown are totally fine. But 25% of the sites in Greenville have greater than 15 parts per billion of lead in the drinking water. So I would tell the governor that he or she, I think in this case, should investigate why the lead amounts are so much greater in Greenville, and of course take whatever actions need to be taken to reduce those amounts. Those poor people living in Greenville, that's definitely not a good thing. But I love how the box and whisker plot made that so easy to see, right? I could see everybody in Oaktown was below 15. Great. But I could also easily see that an entire 25% chunk was more than 15. That's bad. So I like these box and whisker plots. It was kind of quick and easy to see that data. And it was easy to compare the two sets of data. So with this in mind, we've now done dot plots where we put our little X's up above on a number line. We've done our histograms with our bars and our bins and our frequencies. And now you've done box and whisker plots where you can actually compare two sets of data instead of just one. So here's the deal. I have a whole bunch of situations for you. I would like you to analyze each situation and describe which representation you would use. Would you use a dot plot? Would you use a histogram with their bins and bars? Or would you use a box and whisker plot to display and analyze the data set? We're not actually putting these things together. I'm just saying, if you're looking at the situation, which one of these would you use? A dot plot, a histogram, or a box and whisker plot? Go ahead and hit pause, jot down your thoughts on these. I think we've got 4 of them, 1, 2, 3, and 4, and then hit play when you're ready to check your work. So I'm starting off with number 1. Nick collects data about the 100 tallest buildings in the United States, and he wants to quickly determine between which two heights the top 25% of the data fall. So the fact that he said he wants to quickly know where 25% of his information is, that tells me that's a box and whisker plot situation. I saw that 25% and I was like, oh, the box and whisker plot, each chunk was 25%. And so that feels to me like the better choice, right? These box and whisker plots are divided into quartiles and they each represent 25% of the data points. It would just be the easiest one to determine where the information is that he's looking for. Number 2. Lily conducted a school survey to determine how many problems each math teacher assigned for homework on Friday. A box and whisker plot wasn't going to be helpful because I want to see the individual data points, right? I want to know how many problems each teacher is assigning. But that also means I don't really want to use a histogram because the bars come in bins, right? I'm like, this is how many from 0 to 5. I don't want that. I want to know how many problems each teacher is assigning. I want to see that individual information. So that means I'm going to go with a dot plot on this one. Dot plots can be used to organize a small number of discrete data points. And so I don't have big old bins. I don't have a huge box and whisker plot. I just need to know individually. Yeah, that works better. Number 3, the migration ranges of white deer and mule deer populations in Montana are recorded and compared. All right, the fact that I have 2 chunks of data, I have white deer and then I also have mule deer, and I want to compare the 2 sets of data, that tells me I want to do a box and whisker plot because that was a lot easier, right? It's hard to compare data on bar graphs, on histograms, and it's impossible to compare data on a dot plot. I'm just putting dots on there. I don't know who's who or what's what. So I'm going to go with the box and whisker plot. That's the easiest way to be able to compare 2 large sets of data. Number 4, a school district wanted to determine how many students in the entire district scored above 70 on a standardized test. I feel like a histogram would work best for this one, right? If I did bins of 10, right, 0 to 10, 10 to 20, 20 to 50, on and on, then I would easily be able to look at the bars that were over 70 on our test. And so a histogram would probably be the best way to organize that. It's a good way to organize a large number of data points, and you can select the size of the bins, like I said, go by tens, to easily see how many data points will fall above that number. Yeah. So one more, it's not so little, but we got one more problem, number 5. On number 5, I can only fit one at a time on my page, but on your page, on number 5, you can see a dot plot, you can see a histogram, and you can see a box and whisker plot. I can't fit them all on the same page. But I want you to just take a look through and what conclusions can you draw from each display? Go ahead and hit pause and just make some notes on what conclusions you can draw from each of our lovely displays, and then hit play when you're ready to check your work. So first of all, I'm just going to call it participants who won gold medals at the Special Olympics, number of gold medals won. It's just telling me this dot plot represents the number of gold medals participants won at the Special Olympics. So that's one thing I noticed. I also realized, because it was a dot plot, that if I counted up all of my x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, I was like, oh, there are 20 participants on our dot plot. So I was able to tell how many participants we had. There were 20 people that participated. I could see that. And then I started actually looking at the data, and I was like, okay, so we have 2 people who didn't win any gold medals. We have 4 people that won 1 gold medal. 3 people won 2 gold medals, and on and on. Check it out, though. I've got like 1 person who got 14 gold medals. Oh my goodness. I've got 2 people that got 9 gold medals. 1 person got 10 gold medals. And so I'm kind of noticing the data is really sitting on the lower end here. So I was like, okay. So most participants who won gold medals just won a small number of them. And then we had a few participants that, earned a whole bunch of gold medals. Good for them. The other thing is I realized I busted out my calculator and I actually worked some numbers. I could find the mean of this, right? If I'm like 0 plus 0 plus 1 plus 1, and I'm going to do it. So 0 plus 0 plus 1 plus 1 plus 1 plus 1. And then I got 2, so plus 2 plus 2 plus 2. I got 1 person that earned 3, so plus 3. Plus the 2 people that earned 4, so plus 4 plus 4. Plus 2 people earned 5, so plus 5 plus 5. Plus 2 people earned 6, so plus 6 plus 6. Plus we got the 2 people that earned 9, so plus 9 plus 9. We got 1 person who earned 10 and 1 person who earned 14. And I was like, okay, I can take this number and I can divide it by the number of participants, which is 12, and find, or 20, I should say, and find my average. And it looks like my average, my mean is 4.25, but I can even figure out where the middle number is, right? If these 10 are the first half and these 10 are the last half, I was like, okay, well, then right between that, 3.5 is the median. That would be my middle of all my data, right? There's the lower half, there's the upper half. And remember that mode is the one that shows up most often. And I was like, oh, most people got 1 gold medal. So my mode is 1. Interesting. I actually could get a lot of data from that dot plot, couldn't I? What about your histogram? So the first thing I says, I was like, okay, rain in Collinsburg, inches of rain, number of months. Oh, these are months. So 3 months plus 5 months. I got my calculator here. Plus 8 months plus 6 months plus 2 months. Oh, so this is a total of 24 months here, right? 3 plus 5 plus 8 plus 6 plus 2. So this histogram represents the monthly amount of rain that fell in Collinsburg over 24 months. And I was like, okay, well, so there's 24 data points, right? Again, that 3 plus 5 plus 8 plus 6 plus 2. So I have 24 data points. That represents the sum of the heights of my bars in each bin. And I also noticed that most of the data points were kind of clustered around the middle. Did you notice that? But most of your data points were kind of clustered around the middle, and you kind of had an even amount on either side, roughly. The problem with this histogram, as cool as it is, pardon me, is that I can't find the mean, median, or the mode. Like, I have no way of finding this because I don't know what these values are in between, right? Maybe one day we got 2.5 inches or 1.3 inches. I have no idea. So I can't find the mean, the median, or the mode. I don't know the average. I don't know the middle. And I don't know which data point showed up the most often. Although clearly we're somewhere in here between 2 and 3. Last but not least, our box and whisker plot. First of all, I took a look at this, volunteer hours at the local animal shelter, hours per week. And I was like, okay, so the box and whisker plot represents the number of hours people volunteered per week at the local animal shelter. I got my cat, Charlotte, from the animal shelter. And she's wonderful and adorable and lovely. And they took good care of her before I brought her to my forever home. I love her. We're getting off topic. All right. The only thing about this, as cool as this box and whisker plot is, I literally have no idea how many data points are. Right? I don't know how many people volunteered for 10 hours. I don't know how many people volunteered for 18 hours. I have no idea. So that's something I'm going to point out. I don't know how many data points are represented here. I have no idea how many volunteers there are. I don't know. But I do know a few things. So like, here's my first quartile at 9. Here's my third quartile at 14. I do know that half of the people who volunteered between 9 and 14 hours a week. So I do know that. I know the median, right? Look, the median, right? That mark is the median. So it looks like my median is at 11. But since I don't know how many people there are, I don't know my mean or my mode. Because I just don't know how many volunteers there were. This box and whisker plot doesn't give me that information. Well, as always, guys, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, please let me know. Talk to me during class. Email me. Come see me during office hours. You know how to find me. And I'll see you guys soon. Bye.